Hi, welcome to this video on arithmetic sequences. This is a slightly tricky question involving algebra. It doesn't involve straight numbers, and so I thought it would be a good example to have since it's the kind of thing that they can ask you in the IB exam. So the question goes like this: find the number of terms in the sequence, and the sequence looks like this. The first number is given a general expression x. The second one is given something that looks like this, 3x plus 3. We're given also the third number, which is 5x plus 6. Then you have dot dot dot, and then the very last term, because they've got to give it to you, otherwise you can't find the total number of terms. The last term is 19x plus 27. Full stop. The full stop indicates that that's the last term. And this is your sequence. And so here, what are they asking us for? Well, if you remember from arithmetic sequences, we have the letters involved are, normally we use A for the first term, right? Some people use U1 or A1, right? These are the first term. Then you have AN or UN, which is the general term. Any term, for example, A3 would be a particular case scenario of AN, etc. And then we have the letter D, right? This could be UN. And then we have the letter D, D being the difference because it's an arithmetic sequence, right? B being the difference of between these two and between these two. In other words, we're always adding D to get to the next one. So that little refresher, we have then A, D, and N, really, where N is the total number of terms. So here, what are they asking us for? Find the number of terms. So they're asking us for the total N. In other words, this term here is AN, and we want to know what N is. How many terms there are. There could be 10 terms, 15 terms in this whole sequence. So they give us a certain number of clues, and we've got to deduce what N is. And here we're going to have to do some algebra. So let's see. We've got to find out everything that we can about the sequence before we find N. And hopefully you can see that the first thing here to be able to find could be, well, we already have A, the first term, which is just X. That's easy. So we know that A is X, that much. Or A1 or U1 is X, same. Okay, so I do this so that you get used to seeing them in all the different forms. That could also be A1 or U1. Okay, next. How do we find D? Well, if this was, I don't know, if the first term was 5 and the second term was 12, and then the next ones came, how do you find D? Well, you subtract the second term, you subtract the first term from the second term, and you get your D. So you know that that would be D, and that would be a constant throughout the series because this is an arithmetic sequence. But here we don't have numbers like that, but we do have expressions. So we would have to subtract this guy from the whole of the second term. So let's do that. 3x plus 3 minus x equals 2x plus 3. So this is your constant difference. And just to check, you can do it with the next one. 2x plus 3, if I add again, if I get this one here, 3x plus 3, right? And I add d, I should get that one. So let's check. 3x plus 3, and I add d, and d we said was 2x plus 3 from here. Then I should get 5x plus 6. Let's see, 3x plus 2x is 5x, 3 plus 3 is 6, so we get the 6 and the 5x. We get exactly right, so that's our check. Good, so now we have D, and we have A. Our next step is to find N, and to find N we need to write the general expression for D and for AN. So AN, different color, this is a different part of the question. So AN, the general formula, is always, this is in your formula book, it's always given by the first term plus 1 from the n, one, one less than the n, multiplied by d. If you don't know where that comes from, you have to see a previous video from the origin of this, but it's very intuitive. Let's see, so then if I move myself a little bit further down, we can see that an is going to be the last term, which is 19x plus 27, because we're interested in that n, in the last n. An is a general term that applies to everything, but here we're going to make it the last term because that's the one we're interested in. That's the n that we're looking for, right? So let's say that 19x plus 27, which is that last term over there, this here, equals a, which we know is x, plus n minus 1, which we need to keep algebraic because we don't know what n is. That's what the n we're trying to find out, times d, and d is this thing over there, 2x plus 3, which is what we found before, and that will allow us to find n. We need to do some maths now, and it's a little bit fiddly, but the more you do these kinds of questions, the more you'll see that they're a very similar method. You basically have to isolate n on its own, and you're going to have to take out a common factor for that. So let's see, 19x plus 27 equals x plus n times 2x, n times 3, so plus n times 3, minus 1 times 2x, minus 1 times 3. Right, that's just a normal FOIL or distributive property, and now we need to put everything on the left side. So here we have negative 2x and then x, so x minus 2x is minus x, negative x, right? If I join these two, I get negative x. So if I pass it to the other side, I get positive x. So here I get 20x. And here I have, so I've used this one and I've used this one. Then I have minus 3. If I put it on the other side, which is a way of speaking, if I add 3 to both sides, I get 30. And I'm left here with 2xn plus 3n. So I've used this guy too. Good, so now you might be thinking, what do we do now? Because we have n in 2 different places, and we need to have n only appearing in one place so that we can leave it alone and find an equation for n, right? What we have to do, and this is very common in algebra, is to take out the common factor. And that's going to allow us to solve it. How do we do that? We say, well, n is here and n is also there. So we divide by n, and we're left inside with 2x plus 3 only. Now we have the n like that, we can divide both sides of the equation by 2x plus 3, and we end up with 20x plus 30 over 2x plus 3. And this looks messy, and it maybe doesn't jump out straight away what to do with it, but actually we haven't simplified it at the fullest, and when we do that, we'll see what to do. If we simplify this, we see that this has a common factor of 10. We can divide 20x by 10, and we can divide the 30 also by 10. If we do that, we get 10 outside of the brackets, and then we have 2x plus 3. If I multiply 10 by this, I'm going to get that, right? Divided by 2x plus 3, and the common brackets, now this, we can divide top and bottom by 2x plus 3, and I get 1 when I divide that by that. The 1 times 10, I don't have to include it, I just get an answer of 10. So my answer for n is equal to 10, and that's the end of the question. This is one of the most tricky ones that you can do for the arithmetic sequence, so don't worry, all of them are not like this, but if you know how to do this one, you're pretty much sorted for the rest of the topic. Okay, hopefully that was useful. I'll see you in the next video.